This is the first result. And after that, we can use subnet mask for example, with the IP address only, because subnet mask explain the IP address. We can't use subnet mask in a standalone function. And after that, in subnet masks octets, we have only these values. As you can see here, in all of these values, we have some continuous 0, okay, 8 0, 1 again, other bits are 0, 2 1 again, 0 0 0 0, and until for example the 255, we don't have alternatings 1s and 0. Now let me to show you this example. In this example, you can see again the definition of subnet mask. Look at here, subnet mask has 32 bits. Now you know about it. A.B.CD, we can write it in the dotted decimal notation, as you know. And when we are assigning IP address to the PC in these days, we are using classless networks, and because of that, we need to use the subnet mask beside of the IP address, then subnet mask. And after that, the definition of subnet mask is when we are using 1 in subnet mask, this means that the equivalent bit in the IP address is the network bit, and when we are using 0, this means that the equivalent bits in the, for example, or correlating bits to the IP address is the host bit. Let me to show you 3 examples, example 1, 2, and 3. The first example, 192.168.11.255.255.0.0. As you can see, this means that we are using the first 2 octet as the network in this example, in this IP address, and the second or octet 3 and octet 4 as the host bits. The second example, example 2, 192.168.11.255.255.255.0. As you can see here, we have 3 parts. The first 3 parts are network bits because the subnet mask has the value of 255, 255, 255, and the last octet is the host bit, you know it. And here we have another subnet mask in example 3, 192.168.11, with the subnet mask of 255, 255, 255, 128. This means that the first 8 bit, second 8 bit, third 8 bit, and also the first bit of the last octet, the octet 4, are the members of the network bits. This means that here we have 25 network bits, and after that we have also 7 host bits. This is the subnet mask. You know that we are writing the subnet mask in the dotted decimal notation when we are configuring IP address. Okay, you will see this. Let me to show you. This is the IP configuration page. You will see this page in the future videos, but for now, let me to configure one IP address 192.168.11, for example, and then here we need to configure subnet mask. If you don't configure the subnet mask, you will receive one error, 255.255.255.0. That's it, okay? Because of that, in all of the scenarios, when you are configuring IP address, you also need to configure the subnet mask beside of the IP address. In configuration, we are using the dotted decimal notation of the subnet mask. But let me to give you one example. Look at here. In subnet mask, okay, we need to say 255, 255, 255. This means that it's a little hard to repeat the 255, 255 in all of the times of a day, okay? Because of that, we have another easier method. We use this easier method for example, notifying about talking about the subnet mask. And in most cases, we use this easier method only when we are talking, okay? And we are describing subnet mask, not when we are configuring. In most cases, in configuration, we are using dotted decimal notation, 255, 255, 255. But we have another notation. This notation names is CIDR notation. Look at here, CIDR notation, or classless interdomain notation, or classless interdomain routing notation. Don't worry about the abbreviation. CIDR notation, we can use IP / then the numbers of the network bits. Let me to give you one example. For example, here, as you can see, we have 192.168.11.255.255.0.0. You know that with this subnet mask, we have 16 bits as the network bits and also 16 bits as the host bits. You can write 192.168.1.1.255.255.0.0, okay? And also you can write 192.168.1.1 S/16 means the 16 bits of this IP address are the network bits. This is the number of the network bits, okay? In most cases, in conversation, we are using the CIDR notation. This is the CIDR notation. Let me to write here. Look at here. When you say 192.168.1.1/16, this means that the 16 bits of this address are the network bits, and we can say that the 16 bits are the host bits, okay? Look at here. This is equivalent exactly, this is same as exactly this IP address 192.168.1.1, okay, with the subnet mask of 255.255.0.0. Both of them are same. In configuration, let me write here, in configuration, when you are configuring IP address, okay, we are using this method in most cases, not in all cases. In conversation, we are using the S/16. For example, look at here, 192.168.1.1.255.255.255.0. This means that 24 first bits of the IP address are the network bits. We can say 192.168.1.1/24. This means 24 first bits of this IP address are network bits. Both of them are same. Or 192.168.1.1.255.255.255, that's 128. This means that we can say 192.168.1.1/25, because here, as you can see, and as you know, we have 25 bits of the network. This is another method of the presentation of one IP address, CIDR notation. Both of them are same. In most cases, we use the dotted decimal notation of the subnet mask, for example, 255.255.0.0. When we are configuring, when we are talking about the subnet mask, we are using CIDR notation or classless interdomain routing notation 192.168.1.1/, for example, 16. That's it. You will learn about these features because more than this, because you will configure, you will talk about all of these features many times in CCNA and also in the future courses. Very good. Until now, we learned about the subnet mask, but let me to give you another example about the subnet mask. You can use this example for better understanding the usage of the subnet mask. Look at here. As you know, we had this example in the Classful networks. Let me write here. Classful networks, PC1's IP address is 192.168.1.1, and the PC2's IP address is 192.168.2.1, okay? And you know that PC1, because the PC1 knows that its IP address in class C, it can compare the 192.168.1 of its IP address, or 10, the network address, okay? Its network address with the, for example, 192.168.2.0 of the PC2, and PC1 can understand that the PC2 is not residing in its networks, and it can use the router to forward traffic to PC2. It's okay. But let me to give you the similar example in the classless networks. Look at here. This is the classless networks, and in classless network, we need to configure subnet mask beside of the IP address. For example, we can configure 192.168.1.1 with this subnet mask 255.255.255.0, then again 255.255.255.0. Now, the PC1 can understand that its IP address has 24 first bits of network bits, and after that 8 bits of host bits. Because of that, it needs, in this example, to compare 192.168.1, okay, that's 0, with the 192.168.2, that, for example, 0 or X of the PC2. And as you can see here, we have the, two systems in different networks, okay, different network. Why? Because the network part of these two addresses are not same, and this is obvious. But let me to configure another subnet mask. For example, I will configure 192.168.1.1, 192.168.2.1, but the subnet mask is 255.255.0.0, okay, or 255.255.0.0 for PC1 and 255.255.0.0 for PC2. Now, we need to compare in PC1 the 192.168.0.0 with 198.168.0.0 because you know that here we have only 16 bits of networks, and even if you use the 0 instead of the host bits, you will find the network address. You know that you should compare the network address of these two addresses with each other. As you can see here, we have the same for example, the same two IP address, same network address in these two IP address, and because of that, PC1 can understand that, can send traffic to the PC2 directly. But in the first example, the PC1 should use the router. This means that with subnet mask, we can easily find that the destination IP is residing in our network or in another network. We can send traffic directly to this system, or we need to use for example, or give help from the router. This is the function of the subnet mask. Don't forget, classful networks are the fundamental, classful rules, classes rules are the fundamentals of today's networks. But in today's networks, we are using only classless communication, okay? Classless communication has some advantage for us. I will show you the subnetting for example, concept and subnetting method in the next video, and you will learn how you can use the subnet mask to using with the more efficient manner of the space of the IP addressing. You will learn about the subnetting and benefits of the classless networks. But until now, you learn about the subnet mask. In the next video, I will talk about the, for example, usage of the subnet mask. I will talk about the, for example, subnetting method. And finally, you will learn how you can design the IP addressing of your networks with less wasting of the IP addressings in compare of the classful networks. But for now, it's necessary for you to review all of the topics in this video and maybe the previous videos. And after that, please come with me to the next video. In the next video, we will talk about one of the more important and also more interesting parts of the IP addressing lesson. We call it subnetting. You will learn about the subnetting, but it's necessary first understanding the concept of this video, okay? After reviewing all of the features in this video, please come with me to the next video. We will talk about again IP addressing, but now about the subnetting